Welcome to part 2 of my solar system simulation generator thingamabob. So this has turned into a multi-part series. I'm probably going to do 1 or 2 more, but this part, what I'm going to do is take this 2D solar system orbiting thing and turn it into 3D. So instead of circles, we're going to have spheres. Instead of rotating just around in a 2-dimensional plane, we're going to rotate in a 3-dimensional space. So now, before I get to that, I want to make a couple small improvements here. I think I could be a little bit more thoughtful about how I pick the sizes of the planets and how I pick how far they are from the thing they're orbiting. So let me dive into the code real quick before I make this a 3D version and just go down to where that happens. That happens here. Every time I make a new planet, it gets a radius that's based on the previous one. They're shrinking, they're shrinking, they're shrinking. And it also gets a distance from the previous one, which is some random number. And this is what I could really improve. So one thing that I want to do is say, okay, the distance, if I wanted it to be perfect, I lost my, oh, here it is. Oh, no, let me go over here. Sorry for the, okay. So if I have this planet and I have this thing orbiting it, if they were exactly touching each other, then their distance would be the 2 radii, the sum of the 2 radii. So first thing I could do is just show you that. And I'm going to change this to radius plus r. So let me run this now. We should see how do you see how the first one worked? I don't know what happened with the second one. Let's think about this. What did I miss here? Oh, the distance, I'm dividing by level. So I should actually just say that. And now you can see that they're in a sort of precise location. Every single circle is rotating around the edge of the other one. That's kind of a nice effect. I almost want to keep it this way. And by the way, you get some really interesting patterns if you drew like trails where the circles are going. You try that on your own. Send it to me. But I'm not going to go down that road. But what I'll do is I'll just say, why not make distance be random between that exact spot and that distance and that amount times 2. So in other words, I'm saying, let's make a random distance between where this would be exactly, and then this exact amount times 2, so over here. So the planets will orbit somewhere between being exactly touching the original planet, the orbiting the thing, and a little further away. Okay, so okay, here we go. Okay, so now we can see, I don't know, I just kind of like how this looks better. Everything has kind of a more thoughtful spacing, and I don't know if the ratio of the sizes is good, but we'll get worry about that stuff later, because what I really want to focus on is moving to 3D. Okay, exciting. Now's the time. 3 minutes into this video, we're going to add 3D. So the first thing I'm going to do to add 3D, this is going to be a magical thing, is I'm just going to go here, and I'm going to say 600, 600, P 3D. Dun, 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 dun. 3D solar system. There you go. So this is actually now rendering in 3D using Processing's 3D renderer. But of course, I'm still just drawing circles and I'm still just placing everything along that 2-dimensional plane. But it is important to note that Processing, one of the reasons I like to use Processing is that it lets you sort of blend and blur the lines between 2D and 3D because all the 2D drawing stuff in 3D. But let's look a little more carefully at this and start making this even more 3D. So first thing I could do to make this more 3D is instead of drawing an ellipse, I could draw a sphere. So the function to draw a sphere in Processing is just the word sphere, and then sphere takes a diameter or radius. I'm not really sure. Let's try radius. So in an ellipse, notice how I said radius times 2, because I know for a fact the radius, the ellipse function requires a full diameter as the argument, but I think sphere maybe just wants a, does this look right to you? And now, first of all, it's sort of hard to see what's going on. So first of all, you see what a sphere actually is. Everything in 3D is made up of all of these kind of like polygons and shapes, and you can see it's just this mesh of all these kind of rectangles with a line divided, but it's really like a triangle mesh. But we don't want to see all that. What we want to just see, and so one thing that I'll do is here in where I'm drawing it, I want to say no stroke, and I'm going to just say fill 255. And I'm going to do this again. And now look at that. Nothing about this looks 3D because I'm just staring straight at these spheres that are pure white, without a texture, without some shadowing and lighting, I don't really even see that 3D effect. So the one thing I could do just to kind of see the 3D effect is just add the very generic function lights. So lighting in 3D is an interesting and complex topic, and you can have spotlights and directional lights and ambient lights and different colored lights and all sorts of things. I'm going to stay away from that. Maybe someday I'll have the courage to do a video about that. But lights, the simple lights function just generically adds kind of a wash of light into the scene, and you'll see what that's going to do. So now we can see that now this has the appearance, they have the appearance more of spheres. It's very subtle, but there's some shadowing on the spheres based on the lights. Now, this is almost like, hey, we're done. I made this simulation in 3D. Look, and in a way it looks kind of 3D, and I could add some camera work and do some other things, but everything is actually happening all on one plane. And what I want to do, and this, I'm going to try to draw a diagram here just to kind of like work this out in my head, is let's say I have a sphere. What I want to do is arbitrarily, now again, I'm not doing anything that has anything to do necessarily with how the actual universe works. I'm just trying to create something that looks kind of interesting and figure out how stuff works in processing. But I want to arbitrarily create a vector out from a particular planet and create another planet and then maybe rotate around the planet. So there would be all of this would happen. I'm drawing in two-dimensional space, so it's very hard to do, and I have no artistic talent whatsoever, so I can't even really draw this well. But you can sort of imagine, I want to arbitrarily place a planet out here and have it rotate like this, or one out here and have it rotate like this. So the idea is that I want to make a vector, a random vector. So let's do that. And I'm going to go into the planet object, and what I'm going to do is I'm going to add a variable. I'm going to call it v, just for lack of anything else that I can think of right now. I'm going to say v equals pvector.random3d. So this here is a particular, oh boy, I'm not in the right place. Sorry, everybody. That was a little awkward moment there, but I don't know. Maybe some like CGI magic can fix that someday. But so what I created here is a random 3D vector. So any vector pointing in space that is of length 1. And so then what I want to do is multiply that vector by distance. So in other words, I want to scale it by the distance that it should be. So again, if only I had like good spherical things here. My fist will be a planet. Then I make a unit vector of length 1 pointing out. And then I want to scale it by some distance that it should be. And now I have another planet out here. Visual aid. Boy, this is quite pathetic. I need props. Somebody send me some props. Okay, so then when I'm drawing it, let's look down here. I don't want to translate simply along the x-axis by some distance like I did in 2D. I want to translate by that vector, v.x, v.y, v.z. And what I'm going to do here is I'm going to take out rotation for right now and just translate. And we can see what's going on here. And you can see that there are a bunch of spheres. And let me fix a few things. Oh, you know what? I'm going to keep going. So let me fix a few things to make this sort of easier to figure out. Number one is, if you recall, the planets are picking a random number of moons. So I want to just change that to 1. So every planet just has 1 moon. And I'm also going to have fewer levels. So we can see now that when I run this, whoops. What happened here? Okay, wait, pause, time out, time out. Oops, so I forgot that in the original sun, the original planet has 5 moons around it. So I just want to have that start with 1 also. And we can see now that we have something simpler to look at, which is just 1 sun in the middle, 1 moon around that, and 1 moon around that. Okay, I'm realizing something. I'm realizing that this would be a lot easier to look at and understand if I could just really quickly like drag the mouse around and like spin the planets and turn the camera. So even though I intended to do this in a separate video, right in this video right now I'm going to add something called PeasyCam to this example. Okay, so how do you add PeasyCam? PeasyCam is a library, and I'm going to do sketch, import library, add library. Oh, PeasyCam is already added. So, so I've already done that. I don't know when I did that. But by the way, what you'll need to do is here, go to add library, search for PeasyCam, click this, and then you'll be able to click install so that it's installed. And then you shouldn't need to restart processing, but if you run into any issues, just restart processing. Okay, so once you have PeasyCam installed, I can do sketch import library and just select here PeasyCam. And you can see it added some import statements to the top. A library being something that allows you to bring in additional code that's not part of core processing to call automatic functions. And what PeasyCam does is it automatically adds interactive mouse camera work to your 3D thing. So then all I need to do is create a PeasyCam, or maybe it's just a Peasy object. No, PeasyCam object? No. What is it called? Oh, PeasyCam. There we go. PeasyCam object called cam. And I'm going to say cam equals new PeasyCam. And I think I have to say this to refer to this sketch because it's going to control this sketch's 3D view. And then I give it like some number, which is basically I want the camera automatically to look at the center of the world, 0, 0, 0, from 100 units away. So by the way, if I wanted to look at a different part of the world, I could say I want to look at 0, 100, 0. I could add that in as well. But I'm just going to say this, 100, and I'm going to run it. And now you should see, now where is everything? Oh, it's all weird. So why am I not able to like find the stuff and kind of rotate around it in a way that makes sense? The reason is because I had this extra translate in there, width divided by 2, height divided by 2, so that was my kind of like camera work to just like move the origin to the center of the window. Now that I'm using PeasyCam, I don't need this anymore. I can run this and we can see, oh my goodness, look at that. There it is. I'm just like 100 pixels away. And I think if I hit like Command, I can pan or Control, I can zoom in and out. But this is what I want to see. I want to see something like this really easily. And so what I'm going to do is just start 500 units away, start further away. So now we can see this is what I've got. And you can see now the shadowing. You can see there's two. Each one of these has this planet has one moon and that planet has one moon. Let's even remove this and just start now with a single moon. So we can see here I have the sun and a single moon. How can I get that moon to rotate around the sun? Okay, here's how we're going to do it. Now, I'm sure there's some really excellent 3D, thoughtful, smart way of doing it. I'm going to do it in a sort of tricky way that I know works, that I hope works. And I'm going to use something called the cross product. Okay. So let me come over here and let's talk about the cross product. The cross product is, let's say I have two vectors. Here's a vector, here's another vector. The cross product of two vectors is this, a vector that is perpendicular to both of those vectors. So if these were my vectors, I would still also get this particular vector. So the reason why I want to do that is, remember, this is the sun. This is the vector where my moon is. And what I want essentially is for that vector to rotate around the sun like this. So what I need essentially is a vector that's perpendicular. Like I want it to rotate around this axis like this. So in other words, let me try to do this in three-dimensional space. I don't know, props. I have some tissues. They'll be my planets, right? Here's the sun. I'm going to I'm a vector, the moon comes out, and then I have, my fist is the sun, I have this perpendicular vector. I want to rotate. I've totally lost myself. I think if you would just imagine it or sort of think about what I'm doing, it makes sense, right? Because I can't rotate, if I rotate around this axis, this is just going to spin, right? This is the vector. If I rotate around that axis, it's just going to spin like this. I want that whole vector to rotate, so I need a perpendicular vector to rotate around. If this makes any sense to anybody, then I'll be surprised and very pleased. Okay, should practice explaining that. But so how do I get a perpendicular vector? So right here, what I want to do is make another vector. I'm going to call it P for perpendicular. I'm going to make a p vector v. And what I want to say v dot cross. So to get a perpendicular vector, I want to take the cross product with something. Well, what should I take the cross product with? Honestly, I could be smart about how I'm doing this, but if I just pick some arbitrary, I mean, there's a lot of, in three-dimensional space, there's a lot of vectors that are perpendicular to this vector. This one's perpendicular, this one's perpendicular, this one's perpendicular, this one's perpendicular, right? Any of these vectors are perpendicular. So I just want to get an arbitrary one. So if I have some other vector, I'll get something, and I do the cross product, I'll get a perpendicular one. So what I'll do is just say v2 equals new p vector. And I'm going to just arbitrarily pick a vector that points straight out. And you know what, maybe I'll actually just pick something sort of arbitrary. And I'm going to make p the cross product of v, the vector that is actually coming out from this planet to where, out from the sun to where this planet should be. And now I've got some perpendicular vector, and now I can use something here. I can use processing's rotate function. In 3D, you can say an arbitrary axis I want to rotate around. So if this is the x-axis, rotating around the x-axis would be like this. If this is the y-axis, rotating around the y-axis would be like this. Z, rotating around the z-axis would be like this. So the functions rotate x, rotates around this axis. Rotate y, rotates around this axis. Rotate z, rotates around this axis. But if you want to rotate around this axis, you just need to give it the vector and then the angle. And what's the vector I want? The one that's perpendicular to the planet sticking out. So I'm going to say rotate p dot x, p dot y, p dot z. So rotate around the vector from the x, y, and z by an angle. And let's run this now and hope we get something that looks right. Am I not increasing the angle? I don't think. Oh no, the angle is increasing. What did I miss? Time out, everybody. Let me look. Let's look. Is angle first? There we go. Okay, so the angle was the first argument. So look at this. Now I have this planet perfectly orbiting this other one. So lovely. Now, let me just, to be clear, let me draw these two vectors so you can see what's going on, because I think this will make things make a little bit more sense. So let me draw a line from 0, 0, 0, vx, vy, vz. Let me draw that. And I guess I need to give it a stroke here. And I should say no stroke down here. And let me just get the stuff where it should be going. Can you see it? It's very hard to see it in there because it's not, the planet's not very far out. So let me draw it longer so you can see it. I'm going to multiply that vector by 10. There, you can see that is the vector that is controlling where that planet is. Now let's draw the other one. The perpendicular one. This is the axis around which I'm rotating. And now you can see that's the axis around which it's rotating. It's a vector that's perpendicular to that one. So this is just a quick and dirty way to get a sphere arbitrarily rotating around another sphere at some arbitrary axis that's random. So again, you might have some other algorithm by which you want to calculate this stuff. And the cross product that I picked is just some arbitrary vector. I probably could be more thoughtful about that, but this works, okay? So now we can start doing a couple things. One is, let's make sure this is really working by adding, where do we pick? Let's add another level. And you can see now, in addition, this one now has this other smaller one is rotating around that one, and you see all of the perpendicular vectors. Maybe what I'll do right now is get rid of this times 10 thing, and you might still be able to hopefully see everything kind of. You can see these vectors here. And maybe let's get rid of, I'm lost in my own, this has like become fascinating to me, and I like forgot that I'm recording a video talking to anybody, and I'm like, oh, let me try this. But it's useful, I think, to see the lines drawing the vectors, but the point of this really is to do what? Is to not have these lines and to just see these planets arbitrarily orbiting each other. So now you can see, here we go, and I can zoom in and out to kind of get a closer look. And now I'm going to do the exciting moment. How long have I been recording this? Maybe like 20 minutes or so. I'm going to do the exciting moment where the whole point of doing this was to allow each planet to have like a bunch of things. So like, for example, what if I give it the first sun to have 2 moons orbiting it? You can see now we've got something a little more interesting here. And you can see the rotations could be weird enough that you could start to like, it almost looks, well, the speeds could be very slow. The way one is rotating around another while the other one is rotating could make it kind of have this optical illusion of not rotating. But I can assure you that if that everything is rotating around everything else. And then I can also, let's give it 4 to start with, and then let's also allow them, when they create their moons, to do what? To have a random number between 0, let's not give them too many, and 2. So we can see now, look what we've got here. We've got a nice system of many planets orbiting other planets. Everything's spaced out, and everything's at random angles along random axes. So hopefully this gives you the idea of how to get started with creating a 3-dimensional sort of nested solar system where you have a sphere with spheres rotating around it, with other spheres rotating around it, and with other spheres rotating around it. And this code you can find, if you look in the description of this video, you'll find the code for this. And what I'm going to do in part 3 is I'm going to add textures to these planets. So I'm going to show you how you can draw the spheres with other textures and maybe put a background or something else like that to make it feel more spacey. Okay, thanks for watching.